much for coming today. Singapore is about as close to home as a Web3 company can have, so much of our team is based in Singapore. We're very happy to host you all today. Thank you very much for coming. And if you're here, you are interested or curious or a fan or a contributor, participator in FHE. So we'll tell you a little bit today about what we've accomplished so far in Web3 with some of our FHE products. And then we're going to lead into two other FHE founders that'll be following me that are much brighter than I am and can give you some more details on what they've figured out. We're almost 2 years into trying to productize FHE products for Web3. And the whole idea, the reason that we got into this is because Web3 data is meant for public data. And we need to make a quantum leap in security and privacy in Web3. And it's a problem that's been acknowledged by some of the brightest minds in our field, like Vitalik, like Sergey. And the interesting thing about being able to run computation on encrypted data without decrypting it is that it has a lot of great use cases. We just have to find places where it's performant now and where it won't slow down processes. So sweet spots in the tech stack is what we were looking for. And we shipped our first product last summer, which was a FHE data lake, which was really well received, especially in DeFi. So one of the early use cases was imagine being able to combine your Web 2 credit score with your Web 3 DeFi activity, putting it into a data lake, protecting it with FHE, processing it to create a comprehensive risk profile for underwriting a loan. Again, this very well received. The problem is we weren't seeing too much use case there. We wanted to kind of look for larger addressable markets. That led us to our second project, which was encrypting the messaging layer on top of bridges. Now this was a really great solution because bridges are one of the weakest places in all of Web3. It's where a lot of bad actors participate. And working with Chainlink, we're in the Chainlink Vote program, we found that they were building this kind of new Swift network called CCIP. They're working with Swift to build a secure way to bridge assets from public chains into private chains and back again. So they were working with BNY Mellon, BNP Paribas, ANZ and several others, and they were taking bank stable coins. These partners were sending them into Ethereum or major public chains and back again. And one of the issues that they had was that the banks working with regulators had to tell the regulators that, hey, the messaging layer is actually not encrypted, but that's okay because the decentralized Oracle network of Chainlink is the most secure in the industry, we promise. And as you can imagine, that promise was not to appease regulators. So the really great thing when we talk about sweet spots, when you're competing with Web 2 products, you don't have to do very well because the time that we had to beat with our Swift equivalent was basically T+2, it's 2 days to finalize a lot of Swift transactions. So you can run any kind of FHE computation you want in 2 days with time left over to spare. So we found that this was a great solution. We could encrypt the messaging layer, that way that no oracle in the Dawn would actually see the transaction. So this would prevent MEV activity or front running, something that banks are very concerned about when you're moving large volumes of assets from public chains to private chains and back again. But once again, CCIP the bridge market is big, but it wasn't quite as big as we thought we could handle. And we're finding out CCIP so far looks like it will be largely institutionally used in the beginning, not so much for retail. We have 3 Ethereum fellows on the team, and we kept hearing Vitalik talk about this concept of private voting. And in the early days, we thought, well, this sounds kind of like what you like in a DAO. If you've ever participated in a DAO, if you've got a large contributor, they can influence other voters. So if you could create a shared private state for all voting, wouldn't that be great? And nobody could influence or bully anybody else. But actually voting, broadly speaking, in consensus is really effective because you have problems in reaching consensus wherever it might lie, whether it's the POS level or what have you. If you have large stakers, large assets, they can be copied. There are some, obviously, methods in place to prevent this, but they don't always work. So this is straight from Ethereum at the Web3 Hong Kong Festival in March. If you want the best of properties for private voting, you have to actually combine MPC plus FHE, which is exactly the framework that my network has put forth. So we created won't slow down processes, but can give all the properties of FHE, quantum resistant, and this ability to not have to decrypt or to decrypt in the most secure way possible if you need the information. So this is voting security for AI networks. We were early contributors into BitTensor, and we found that there's a framework that a lot of AI networks are using, which is that validators are ranking models. So you've got miners making models, and you've got a network of validators that are confirming those models and ranking those models for effectiveness and reliability. And what we saw was a lot of the miners were jumping to the other side to rank their own models. So there's a little bit of conflict of interest there, and there wasn't any solution proposed by BitTensor to solve this problem, so all the subnets had to figure it out for themselves. Secondly, if you have a validator with a lot of DAO tokens staked, it kind of speaks to the fact or hints that they might have a lot of resources and a lot of assets, so the validators, other validators would copy the lead validator to increase their chances of actually getting the token rewards for that particular consensus. So it was called a lazy node problem. So this was rampant, and every AI subnet that we spoke with came back to us and said, this is a real problem that BitTensor doesn't solve for us, we have to solve on our own. And what we found was, getting back to this point of a sweet spot, there's typically about a 10 to 20 minute window allowed for this kind of consensus to be achieved, for validators to confirm and to rank these models. How they rank them is up to them, that's designed by the network, but usually they allow this kind of 10-minute window, so that's perfect. We can do solid FHE computation inside of that window without a problem. And then partnered with Zama, all the great FHE projects are consuming something from Zama, whether it's their Concrete ML SDK, whether it's their Threshold TFHE, or the EVM library. We were already partnered with them, but we learned that they created this Concrete ML SDK for hosting and making models. So they have a way to add FHE to the data input on the miner side for model making, and of course we bring the validation side. So in that framework that I'm discussing, we now have FHE being infused into the miner side as well as to the validator side, and this is the closest thing the market has to date of an actual FHE AI solution. We won't have complete FHE end-to-end in AI probably for a few years, we don't think, unless the chips accelerate completely out of control. We're hoping that might happen with project partners like Optalysis. But for now, this is the most FHE solution you're going to find for AI in the market. And so Zama and my network are actively pushing this into the market and looking for use cases all the time. Now let's talk about token economic security. So we introduced a new term that we put a lot of thought to called total governance value. So if you look at this rising subsector within DeFi called restaking, you have a lot of assets that are sitting idle. Every single restaking project has to play the TVL game. It's the main way that they build credibility, because actually creating the smart contracts for restaking tokens is not terribly difficult. It's not a crazy technology or innovation. So the way to build legitimacy and credibility is to build up your TVL, get $1 billion or $500 million or $2 billion, and that's how the market knows that you are legitimate, you are secure. But then those assets are sitting there idle. Now the stakers are getting rewards, of course, but there is a heck of a lot of governing power sitting idle in TVL vaults. So billions and billions of dollars. And what we thought was really interesting was that 5, 6, 7 years ago, when we were looking at tokens in the market, you're looking for what's the governance of the token? If I buy this token, what does it do? And then the market quickly figured out that these chains didn't really have any important activity they were doing, so you were governing essentially nothing. There wasn't much to govern. What do you really need that voting power for? And so the narrative shifted, and for the last 6, 7 years, we've been asking of tokens and of new founders, what is the utility of your project? I want to know what the token is actually going to do, not just what it governs. I don't care about what it governs because no one's using your network yet, right? What's interesting now is that these AI networks essentially are operating as brand new L1s, L2s. They've got use case, they've got utility. What they need is governance, to kind of return back to this earlier concept. And you've got all of this idle governance sitting in TVL, sitting in vaults with restaking partners. So my network has basically created a framework to bring FHE to secure the not complete transfer. We keep a ledger of source chain, destination chain, but we basically decouple idle TVL from governing power. So you can point the governing power sitting in these vaults of restaking projects, restaking tokens, to AI networks that actually need that governance, right? So this has turned out to be a really cool use case. We call this, again, total governance value. So we're not actually playing the TVL game ourselves. This doesn't always go into our vaults. In some cases it can. But we don't want to compete with restaking. We just want to add utility to the restaking tokens and help our AI customers, which are consuming our FHE validation for their own consensus between miners and validators. And so on the left-hand side, you'll see some of our partners for sharing total governance value. On the right, these are AI partners that will be consuming our FHE validation to secure their networks. And like I mentioned before, we've been researched in Cornell and Ethereum. We have 3 Ethereum fellows, one of whom is here today. He wouldn't like it if I shouted him out, so I won't, but you can find him in the back. His name rhymes with George. We did successfully close testnet in the spring. We're in private mainnet now. Public mainnet will be happening shortly. So it's a very exciting time for us. And we're very excited to be a part of this very unique team of builders and other projects in Web3 trying to bring FHE, quantum resistant computing, to the industry. So thank you all very much.